So now let's deep dive on the definition of each node of each component. Okay, remember you have seen those component: monitor, manager, OSDs, okay, MDS, and so on. We will define it. We will define them right now in the following, okay, parts. Okay. So what is the monitor? The monitor or the mon. Let me come back here and show you. Okay. In this dashboard, for instance, I have 3 monitors. Okay, and I have 2 managers, 16 OSDs. I have 13 pools, and so on. But now we will define what is a monitor and what is the importance of this monitor into your Ceph storage cluster. The monitor is responsible of the cluster map. First, the cluster map is 5 maps that register the whole information about the list of the OSD, the list of the PGs, the list of the monitors that we have in your cluster, the list of the MDS that we have in your cluster. So all those information are keeping updates on the monitor part. Okay, and this monitor which will be able to send this information to any client who would like to communicate with this cluster. Okay, so this monitor, this mon component have the monitor map. Okay, the cluster map, the 5 maps, and if external customer want to communicate with the cluster, this monitor will send out the 5 maps to the client, and based on this map, the client will be able to locate where to store data. Okay, so to be sure that this monitor are very resilient, the default number of the monitors that is recommended is at least 3. Okay, and you should have an ODD numbers of monitor like 3, 5, 7, and so on. This is the number that you should very follow when you have to deploy your monitor component in your cluster, definitively. And the monitor communicated, okay, to have they are in clustering. Okay, and among the number of monitors that we have a leader monitor. Okay, and the others are just the standby monitors. Okay, so we have a leader which is involved to be, okay, you are the master of the primary monitor, and you are the master of our monitor. Okay, so let's come back here, and the monitor is the component which manages the authentications. When a client wants to communicate with the cluster, it is the monitor who have the responsibility to authenticate this client. Okay, on which pool do you want to write? Okay, what are your different writes? Is it read, writing, or execution? So this monitor will check all write of any client before granting access to this client to the cluster. Okay, so the authentication is managed by the monitor. We have also the whole cluster configuration, which is centralized on the monitor part. So the monitor is the strategic component in your cluster. With no monitor, no access to your cluster. With no monitor, no access to your cluster. Okay, it's very important to understand that point. And regarding the sizing, depending on the size of your cluster, we can have 3 monitors for the smaller cluster. If you have a medium size of monitor, you should have 5. And if you for a very large cluster, you should have 5 monitors, as I told you. Okay, it's very important component, a strategic component in your Ceph storage cluster design. Let's go to the OSD. The OSD, an OSD is first, let's define it. It's object storage daemon. It is a daemon which is involved to manage the drive or manage the disk. This is the OSD which is involved to store the actual data that you have that you intend to store in your cluster. This is the OSD. Okay, and you can have, of course, many OSDs. You should have many OSD in your cluster to be able to handle the data distribution in your cluster. As you can see here, the OSD can have OSD 1, 2, 3, 4. As you can see here at the moment, I have those OSDs and the OSDs which are distributed across all the different nodes that you can see right now. Okay, and of course, each node have its physical disk, and on each physical disk, I will be able to configure one OSD. Okay, so one OSD for one drive, for one disk. Okay, by default. But you can, by default, this is the default configuration. One OSD for one disk. If this is the default configuration. On another optimizer configuration, we can have different configuration, but the default one is one OSD for one drive by default. Okay. Of course, so in another configuration, you can have one driver where we will be able to assign different OSD, but the recommendation is one OSD for one drive. Okay, for one disk, definitively. Okay, so let's come in back here. So here is the sizing, okay, of the different OSD that you may have in your environment. And another characteristic of the OSD is the backend storage that you use the OSD to write in the data. The OSD, in the OSD architecture, we have something called the Blue Store. The Blue Store is the component that is involved to manage the actual data writing on the drives. Okay, so I will come back to this OSD in another slide, which is coming. But you have to keep in mind that the OSD is a daemon, and before this daemon will be capable to write data on the driver, it will rely on the Blue Store component. Okay, and on each Blue Store, or on each driver, you have already the PGs that are distributed on the different drives. Okay, when the OSD daemon is working, okay, how it proceeds. First, all OSDs monitor others OSD and report it to the monitor. Okay, it's for the OSD mapper or the cluster map, because the monitor have to know which OSD are up or which OSD are down. So this information has been collected by each OSD. Okay, so there are the peer-to-peer independent monitoring, and they report it to the monitor. Okay, and the monitor will update the cluster map. Okay, so the OSD manages the hard disk data storing. Okay, you store data and sell data to the client who would like to store the data. Okay, and when this fail, the associated OSD also fail, of course, because it is a daemon. If a disk fail, it will not able to store data inside this drive, this disk, and so this is reported to others OSD, and others OSD send the information to the monitor, okay, in order to update the cluster map. As soon as the cluster detects that one OSD is failed, automatically the data will be distributed to another OSD in the cluster. Here, for instance, let's suppose that this OSD have some data and it's failed. If it is failed, okay, the cluster will detect that this one failed, and all data that was here, the cluster should have others copy in others OSD. Okay, so if, for instance, the data should have 3 copies, so I have one copy here, and one copy here. If I have one copy here, one copy of data here, and one copy of data here, if this OSD failed, okay, this means that it remains in the cluster 2 others copy. Okay, so what the RADOS will do, it will say, I have just 2 copies in the cluster, but I'm supposed to have 3 copies. So automatically, the RADOS will take this copy which is here and duplicate it here to another OSD. So by this way, this is the self-healing procedure. Okay, the Ceph healing commands that if one node is failed or if one component is failed, okay, all the remaining copies of data will be duplicated on the another node just to ratio the number of minimal copies that you should have for this particular data, definitively. And this is about the Ceph healing. Okay, so let's move on. Yeah, and the OSD have the concept of primary OSD and secondary OSD. The primary OSD is the OSD that receives data from a client and write it on its driver, and the secondary OSD are the OSD that receive data from the primary OSD. Okay, so the client first write on the primary, and the primary OSD take care of the writing of the data on the secondary OSD. This is how the OSD works together. So just come back to the key information: one OSD, one daemon processor, one disk by default. Okay, and there is direct communication between OSD. Okay, direct between OSD, no central controller. So the OSD, all OSD have to monitor each other, okay, directly. Okay. So the auto healing, I already talked about the auto healing. So automatic reconstruction after one OSD failure, automatically. Okay. And the backend component which is involved to actually manage the data is the Blue Store. Okay. And the different state of OSD are, come here. Here is the different state of the OSD. Here you have it in app. App means that the driver is inside, okay, and the daemon also is ready, is app, okay. In means that we can write data on this OSD, okay. App means that the driver is inside, or the daemon is app, okay, and in seems that we can write data on it, okay. So here is the different states that we can have. You should have on the OSD. In app, ideal. You can have down and up. Okay, this means that this OSD is out of service. You can have up and out. Okay, the OSD is there, but it's out. You can have access for writing information. Okay, but if you have in and down, okay, this means that cluster is in trouble. Okay, so we can check it. We have some command. We can. So as the state to check out the status of the different OSD that we have right now. You can see that we have 16 OSD app and 16 in. Okay, we can have the Ceph OSD 3, for instance, to see some information about that. Okay, we can do also the OSD DF to see the data occupation on the whole cluster and so on. Okay, and let's move on. Let's talk about the Blue Store. This one is the daemon, the backend component of which is actually store the data into the different drives. Okay, the Blue Store have three parts. We have the data part, the whole part, and the RockDB part. Okay, so this is the characteristic of Blue Store and how this Blue Store store data actually on the drives. Okay. Okay, so in the upcoming years, you should have a new component for the OSD. The project is ongoing, and I think that in the 2 or 3 years, the OSD, the current OSD that we know right now, will be replaced by the Crimson-OSD, which will be the new OSD, which will be take place. Okay, why this project has been taking place? It's about when we have NVMe, the actual OSD can't fully, okay, ratio the million IOPS that you can have with NVMe. So the Crimson OSD project comes to be able to reach this million IOPS that you can have with the NVMe drive types. Okay, so this project is ongoing, and I think that within 1 or 3 years, okay, this will be able to replace the current OSDs that we have right now in our Ceph storage cluster. It will be a very significant shift from the well-known OSD that we know right now, and it will be a new architecture. I just introduced this slide to let you know about what is ongoing right now in the Ceph development. Okay, let's talk about the MGR. The MGR, which is this one, the MGR is this component which is responsible of the metrics. All metrics of your Ceph storage cluster are being stored in the MGR. Okay, this is the component which is also embeds the dashboard. Your Ceph dashboard is managed by the MGR. It's very important. If you lose MGR, you don't have access anymore to your dashboard. Your cluster will still be accessible. Be careful. If I lose all MGR, okay, my cluster will still be accessible from by the customers. Okay, they will be able, they will still be able to have access to the cluster, but me as administrator, I will not have access anymore to this dashboard. Okay, this dashboard is stored in the MGR, okay, server, okay, on the MGR components. Okay, so if I lose the MGR, automatically I won't have access anymore to this dashboard. Okay, but customer will continue to have access to the dashboard because to the cluster for read and writing, because I have monitor and I have also all OSDs which are still up. Okay, great. So let's move on. We have also the MDS. The MDS, okay, let me talk about the MGR. Also is about everything about monitoring, the Prometheus, the PG, auto scaler, and so on. All those components are being managed by the MGR. Okay, and let's talk about the MDS. When it comes to use of the file type storage into your Ceph storage cluster, you should deploy the MDS. It's not a default component, but it is an actionable component, depending if you want to have access to the file. If you want your cluster to provide a file type storage, you should deploy the MDS server component. Okay, and only required if you want to use the CFS, okay, for the file type storage. Yeah, and it works with dynamic cache. You can have multiple MDS for the high availability. Okay, and the MDS just store the subtrees or partitions of your cluster, as you can see here. Yeah, and what I have, if you have some list of the different status of the different status of the different file systems that are right now in my cluster, it's possible. Here I have this file system called CFS. I have based on the different pools, but I will define in the upcoming videos what is pool and so on. Okay, don't worry, okay, about that. I will define everything to you. Great. Now let's move to the next part. The cluster map, very important component, very important. I can say things to know. Okay, the cluster map is the list of the different maps that you have into your cluster. The cluster map. In the cluster map, you have a list of the different monitors that we have in your cluster, which monitor is up, which monitor is down. So it is a list of the monitor first. The second cluster map component is the OSD map, which groups of the list of the OSD that you have in your cluster. Okay, if I say, for instance, Ceph OSD dump, for instance, I will have the list of the whole OSD that I have in my cluster. And this one is grouped into a list of which we call the Ceph OSD map. Okay, we have also the monitor map. I already talked to you about that. Yeah, we have also the PG map, the list of the PG that we have in your cluster. Okay, here, for instance, if I say Ceph PG dump, I can have a list of the different PGs that I have in my cluster. Okay, definitively. If I want to list I want to list the list of the PG for a specific pool, it's possible. Okay, so let's move on. You have also the crash map. The crash map is your physical topology, okay, and the logical topology of your cluster. So if in your data center we have 3 racks, 4 racks, okay, and into each rack I have one server, for instance, your crash map should reflect your physical topology, and this topology is set here in this crash map. In this crash map, it is mandatory for you when you deploy a Ceph cluster, update your crash map, because if you don't do it, Ceph will suppose that your whole servers are just on one room, okay, and yeah, there is no rack and there is nothing. Okay, if you deploy a Ceph story cluster, okay, update your crash map to let Ceph to know about your real servers distribution in your physical environment. You should tell to Ceph that we have 3 racks, 1 rooms, 2 data center, and so on. Because Ceph don't know that. Ceph don't know that. So you have to tell to Ceph that I have 3 racks or 4 racks and so on. Because by default, here is what Ceph knows. Okay? Ceph thinks that we have only host, okay, and nothing else. So it means for Ceph, we just have your whole servers are into only 1 rooms, okay, on the ground. This is the point of view of Ceph. So we have to tell to Ceph that if this is not the case, I have racks, I have rooms, I have some rows, I have some data center, and so on. So we have to tell to Ceph storage that if this is my physical topology, and let's update my logical topology to reflect the physical topology. It's very important, and this is my urgent update for you. So don't let the default topology goes to the production. Never do that. Never let the default Ceph topology go to the production. Never do that. Please, never. Okay. Let's move on. You have also the MDS, list of the different MDS that we have in your cluster. Yeah. Okay. Now we have, after this part finished, we have seen the different components that we have in your self-storage architecture. I mean, this part at least. Okay, we have seen this part, all components that are a part of the backend storage, as you've seen after this part. So now let's see how Ceph manages the data distribution into this backend storage. Okay, so in this upcoming part, I will show to you the definition of pools, the definition of pages, the definition of objects, and so on. I will show you also how Ceph manages to store data into this cluster, the different steps followed by the data before being stored into the OSD and the drives. I will show you all step-by-step action done. Okay.